Welcome to This Explainer. Okay, if you're regularly spinning up AI coding assistants, you already know the drill. Your terminal can turn into an absolute mess in a matter of minutes. Well, today, we're looking at Herdr. It's a lightning-fast, Rust-based tool that essentially transforms your standard everyday terminal into a robust, centralized control room for an entire fleet of AI agents. Okay, let's dive right into this. Here is our roadmap for today. We'll be covering 1. The multi-agent bottleneck, 2. The detachable brain, 3. Detecting state and persistence, 4. Letting agents drive, 5. Isolated agent workspaces, and finally, 6. Growth and reality check. Starting off with Section 1, the multi-agent bottleneck. To really get why Herdr's design is so crucial, we first have to look at the exact friction it eliminates. Picture this. You've got Claude Code running over in one pane. Maybe you have Cursor doing its thing in another, and Codex is turning away somewhere else. Suddenly, your production just slows down. You look at your screen and you have to play this guessing game, right? You're asking yourself, wait, which agent is actually stuck? It is incredibly easy to lose track when just one of your agents quietly stalls out simply because it's sitting there silently waiting for you to give it the green light to proceed. Because, babysitting one single AI agent, that's simple enough. You just watch the screen. But the true bottleneck rears its head when you make the jump to running 5 or 10 agents simultaneously. The core problem completely shifts. It's no longer about how do I start another agent. Instead, it becomes how do I manage a whole fleet of them without totally losing my mind. Herdr was designed explicitly around this reality, the reality that you are going to have several AI agents running at once, and you need to know exactly what the whole shebang is doing at a single glance. Moving right along to Section 2, the detachable brain. And this brilliantly illustrates our first major architectural pillar. To solve this management nightmare we just talked about, Herd relies on a fundamental shift in how you work. Basically, your terminal acts as a background server rather than just an application window that you open and close. Think of the background server like a continuous TV broadcast. The show just keeps playing regardless of whether anyone is actually sitting on the couch watching it. Your client window, that's just the TV screen turning on and off. This means you can kick off a massively complex agent task at your desk, shut your laptop completely, and the actual processes just keep right on running on the server. Later on, you can check in via your phone over SSH, and boom, you're tuned right back into the exact same broadcast mid-scene. This detachable brain concept is the absolute foundation that everything else here is built upon. Which brings us to Section 3, detecting state and persistence. So keeping the agents running in the background is great, but that's really only half the battle. If you can't actually see them, how on earth does the system know when they need your attention? Well, Herd uses two incredibly clever strategies here. For modern agents that support deeper integration, Herd uses direct hooks. It gets told explicitly, hey, I am working, or hey, I am stuck. But for the older or less integrated agents, Herd basically acts like a human glancing at a monitor. It cautiously reads the pixels as text, essentially pattern matching the visible shapes of prompts to guess if an agent is waiting for approval or if it's actively typing. And because it deliberately errs on the side of caution to avoid spamming you with false alarms, if it isn't completely confident in what it's seeing, it simply defaults to showing the agent as idle. Now, beyond just detecting state, there's the whole issue of memory, because persistence is actually more of a spectrum. There's a massive, massive difference between merely rebuilding the visual layout of your panes after a server restart and an agent natively remembering its actual conversation history. Herdl handles both, but they are very different mechanisms under the hood. Detaching and reattaching keeps everything perfectly alive, for sure. But say your background server actually has to restart, like after a system update, Herd can absolutely restore that cosmetic visual layout. However, the real agent memory, actually resuming the context of a deep coding conversation, that relies on the agent natively supporting a resume command. If that command is available, Herd is smart enough to automatically trigger it. Now into Section 4, letting agents drive. All right, we are transitioning to what might literally be the most novel and fascinating feature of this entire architecture. What actually happens when we stop treating AI agents merely as subjects to be monitored and instead we just hand them the steering wheel? Herd exposes what it calls a local control channel or a socket API. To put that into human terms, it means the exact same interface you use to control Herd is also available to the agents themselves. So an agent sitting in one pane can use this API to kick off a second entirely separate helper agent in a neighboring pane. It can read the contents of that new pane and programmatically wait for that helper to finish its task before continuing its own work. It is essentially a shared control channel that unlocks some incredibly complex multi-agent orchestration. Now, before you start worrying about rogue agents taking over your entire machine and wreaking havoc, let's talk security. There is a very simple but absolutely vital built-in guardrail here. An agent will only attempt to control Herdr if it can actively confirm it is running inside a Herdr-managed pane. That basic, essential check keeps these agents safely sandboxed right in their own designated lanes, completely preventing them from reaching outside their intended scope. Let's move to Section 5 and see how this builds into isolated agent workspaces. So, if you have multiple agents running simultaneously on the exact same project, how do you stop them from stepping on each other's toes and just constantly overwriting each other's files? Well, the answer lies in Git Worktrees. Conceptually, this is a native Git feature that lets you have multiple, entirely independent working copies of the exact same repository, checked out at the exact same time, just on different branches. This entirely prevents file collisions because they physically aren't sharing the same directory state. So what Herdr does is wire this awesome Git capability directly into its own interface. When you spin up a new agent, Herdr can automatically provision a clean, isolated folder tied to an independent branch specifically just for that single agent. This completely stops one agent's half-finished, maybe totally broken edits from corrupting another agent's absolutely flawless work. And the best part? When they are done, Herdr can just automatically clean the whole thing up. Finally, Section 6, Growth and Reality Check. We have covered a lot of the architectural pillars, but it's really important to anchor this explainer with some objective data. Looking at the hard facts, Herdr is written in Rust, and it's distributed as a single binary. From our research, we found no documented telemetry policy for the binary itself. As for operating system support, it's currently stable for Linux and macOS, while Windows support is strictly in a preview or beta state right now. On the legal side of things, the current license is AGPL 3.0-relator. However, it is super important to note that a relicensing to Apache 2.0 has been proposed by the maintainer and is currently in progress, though it's not yet fully completed. The growth metrics, though, they are certainly eye-catching. The project boasts over 17,000 GitHub stars, and according to the project's own stats page, it has reached 167,610 total installs. Now, we must explicitly qualify that these figures are self-reported by the maintainer's own methodology, and they are not third-party audited. But still, they certainly indicate a rapid, massive surge in visibility for a project whose first commit was only in March 2026. But hey, massive visibility always brings massive scrutiny, right? In community discussions, like this one really large thread over on Hacker News, there is a very active debate about its core value. Some commenters argue that Herdr is essentially just, quote, tmux with better defaults. Furthermore, there are scattered, unverified reports from some users who are experiencing input lag or weird copy-paste quirks within specific terminal setups. We impartially share this just to demonstrate that while the tool is growing incredibly fast, it is still a very young, evolving project that is shipping rapid fixes. So when we recap the 5 architectural pillars we just went through, persistent detached sessions, screen scraping status detection, resumable processes, control sockets, and Git Worktrees, we realize something. None of these established techniques are actually exotic on their own. I mean, we've had to touch sessions for decades, right? But Herdr's real contribution to the ecosystem is how it so tightly combines these specific, proven techniques into one lightweight tool, explicitly designed from the ground up to supervise a fleet of AI coding agents all at once. Which leaves us with a pretty fascinating prospect for the future of development. We've seen how a tool can give an AI agent the ability to spin up its own helpers, monitor its own isolated workspaces, and even dictate the flow of the terminal itself. The technology is here, the architecture is totally sound, and the adoption is rapidly rising. So the only question left is, are we ready to trust AI agents with the keys to their own control rooms? It's definitely something to think about as you spin up your next coding assistant. Thanks so much for joining me on this explainer, and keep exploring.